Go live. Okay.
Okay.
So we have a few participants already. Okay. Awesome. So everyone was already joining a minute earlier. That's good. Please feel free to write in the chat where you're calling from. And it's 2, but of course we'll give it just another 2 or 3 minutes. Vancouver, Canada, hi.
India, okay. Philippines, okay. Ventura, California, really? I used to live there.
So I'll just do this. We'll start again. We'll start in about 2 or 3 minutes. Okay, I just want to have, we have about 360 participants. So we'll just give it another minute or 2. Belgium, we've got people from all over. That's awesome. Netherlands, Saudi Arabia. That's awesome, guys. Just please keep writing where you're from. We'll start another minute.
Mr. De Bruyne from Connecticut here.
Yes. Let's go. Someone writes. Someone is ready. We're almost there, almost there. We're at 150 participants. We're about halfway. A few more seconds. So it's really exciting. Thank you everyone for joining. I'll already start. We have people calling from all over the world during the special time that we are all in. And we thank you for joining. And we're truly hopeful that you all are doing well, you and your families. And I'll just give it another 30 seconds and we'll start. If you just joined, please go in the chat. You can write where you're from, where you're calling from, or maybe just send hi to everyone. I just want to mention that this webinar is recorded, okay? So if anyone, of course, would like the slides or this actual live recording, we can share. All right. So as I mentioned, hi everyone, thank you for joining. We have people calling from all over the world, which is fantastic and exciting. I'm just going to share my screen for a second. So hi everyone, I'm Yoni Feldman. I'm the Regional Marketing and Product Development Manager based in Singapore, and I'm overseeing all of Asia Pacific for Laticrete. So today, live webinar, it's about 3D construction printing, which is a revolutionary new era that a lot of talk has been around it, but today actually we want to dive into some of the actual projects that are taking place around the world. We'll give you the scope of current and future trends in 3D printing. And I want to first start by introducing our panelists. So we have Matthew Carli, who is the Director of Innovation and Strategic Planning at Laticrete International. So for those of you who do not know Laticrete International, we are more than 60 years old. And one of our founding principles is innovation. What we specialize is flooring products, tile and stone adhesive, waterproofing membranes, grouts, tile and stone cleaners. And that's what we've been doing for more than 60 years. Recently, in the last couple of years, we started looking into innovation in different sectors of our core product lines. And this is where Matt comes into place. Matt is leading our innovation efforts that are more blue sky and more visionary projects around the world. And one of the prime examples of this efforts is 3D printing. So Matt is joining us from Connecticut, which is 2 a.m. So thank you, Matt, for waking up early for us. Next, we have Edouard Baakilini, which is the CEO of 3D Vinci Creation. Edouard comes with a vast experience from the world of technology. Okay, anything from the semiconductor industry to enterprise information system, and now more into bringing technology and digital into the construction world. What's unique about 3D Vinci Creation is that it's not theory anymore. A lot of 3D printing around the world is more proof of concept or universities. 3D Vinci Creation are actually doing live projects. Edouard and his team are based in Dubai, which is kind of the forefront of this technology and innovation. And he's going to talk about the actual projects that are taking place around the world and in Dubai. So without further ado, I'll hand it to Matt. We'll start the presentation. Once Matt finishes his presentation, we'll do a Q&A. So as you can see, there's a Q&A button. Just put in your questions and we'll address them accordingly. And then Edouard will take it from there and we'll have a Q&A specific for Edouard. So Matt, please take it from here.
All right, good afternoon, good morning. The jet lag in the age of coronavirus here. So let me share my screen. All right. Almost. Okay. So I like to frame 3D printing, start off a little bit talking about the digitalization that's happening anyhow in construction. So that's why I call it the Trojan horse that's forcing the digitalization of construction. Yoni gave you a little background of Laticrete. So just again, this is being recorded. We can share everything after. All right. So what it is I'll be talking about today. So the construction megatrends. We'll start off with what's happening with coronavirus. Global 3D printing update. I'll do part of this. Edward's going to wrap it up as well with a lot of other projects globally. Some of the barriers we're facing to implementing taking 3D onto job sites today. And then leave you on the high note of the disruption of what 3D can offer. All right. So 3D printing, we see in the news lately in China, these little quarantine pods. So this may be publicity to some extent. They donated 15 pods, a company in China, Winsun. The bottom left picture is their pods. They're little 3 meters squared little rooms to quarantine in. They donated 15 of these. So it's a start. It's getting some traction for 3D printing. Scalability and what the demand is, I don't know, but worth noting. Another one that we've seen change gears here with coronavirus is Twente Additive Manufacturing, a partner up in Canada. So they're working with the Ministry of Housing of British Columbia to do micro houses that were in areas of Northern Canada with First Nations people that they can't find laborers right now. And with the construction shutting down in some parts, this is a solution that 3D arises to the occasion. Another thing we're seeing with coronavirus is an increased use or new adaptation of technology. So I chose 4 examples here. 2 on the top are making job sites safer. This is not just out of benefit, it's becoming requirements in a lot of places to have social distancing in place to document everything possible. So really nobody knows what's happening in regards to workers' comp, in regards to job site safety. But here in the US, we haven't shut down construction completely. We're still seen here as what's called an essential business. So we're allowed to continue operating despite quarantine, shutdowns, self-isolation, etc. But we're also a very litigious society. So making sure that everything is captured and all your workers are safe is a new concern. So the top left example, SmartVid, is documenting using video. If they're wearing a hard hat, now we're going to start including, are they wearing the proper face respirator, face mask? Are they maintaining the social distance? Do you have too many people on the job site? The top right example, Quant AI, is a New York-based company that's got badges that people are going to be wearing on the job site. They're already connecting this to the BIM models to see progress and schedule movement. But they added a distance alarm. So when you're within the 2-meter space, it starts to beep, again, promoting social distancing on the job site. The bottom two solutions are more removing people from the job site. So you have an example, Built Robotics is fully autonomous excavators that are preparing the job sites. And again, with the idea, tech adoption, and data, if you have these fully autonomous vehicles that are preparing the job site, what are you receiving when you receive a project? You're receiving a digital map of the job site. So that when other equipment arrives, you now have this digital twin to work off of. Last example here, Bolt Company. So Singapore, the host here, is one of the world leaders with modular construction. This removes people from the job site, helps them control it, workflow and people in a factory setting. Additionally, it also makes it so it's planned early into the construction process, just like you'll see here with 3D printing. Additional kind of side note on what's happening with coronavirus. This is an article from Harvard Business School, why COVID-19 raises the stakes for building health. So people are starting to question other aspects of a building, and it's not just location, location, location. This article is basically saying that you can get higher rents if your building is a healthy environment. So green is not necessarily equal to healthy. So questioning the materials, the complete output of the building as a product is eventually going to work its way into higher rents, higher cost of a higher premium product. And again, you'll see this, how it connects to 3D printing in a minute. Additionally, as part of the mega trend is some of the changing world factors we're seeing. So increase in natural disasters. The picture on the left here is wildfires from California. I think this year or last year, we saw some in Sydney as well. Again, definitely a trend that's increasing. So building materials choice is paramount here, that you want a non-combustible material. We're also working with a company in California to do house repairs for the burnt areas. So building new subdivisions, building new homes where there was already a housing shortage, the fires just made the situation even worse. The picture in the middle here is Mexico Beach, Florida. This is the only house left standing. He built it himself, went way in excess of code, but also, again, materials choice, the right material that's gonna keep your building there for the long run. The third one is population, and definitely, again, housing already in a shortage crisis, available economically feasible priced homes is in a shortage globally. There's definitely a shortage of toilets as well in India. So as we start seeing more and more urbanization and population problems, this is where 3D printing could also be a solution. And I wrap 3D printing into the larger area of construction technology. So I think everyone's seen this slide of McKinsey that says productivity is essentially flat within the construction space. It's 1% increase over the last 20 years. And we're 13% of the world's GDP, so one of the largest industries globally. Last year, though, fortunately, there was $6 billion globally invested into construction tech. That's thousands of startups globally that are working to solve this productivity issue. And we are seeing, again, more of this tech adoption. 55% of companies are claiming that in the next 2 years, they'll be using some sort of digital twin in their planning and development process. But still, it's a very complicated industry to be disrupted. There's often up to 80 trades on a job site. So while we're seeing this push for productivity, we'll see how these all converge here, and again, how 3D is part of that solution. So talking about the convergence, first, let's look inside the construction space. So there's again, this increase of data that's happening. People are recording their processes, they're understanding how a project is constructed, and starting to analyze it in new ways. And also having AI and SaaS as a service is making that just exponentially easier. Then there's the technology, the hardware side, like 3D printing, modular, these autonomous excavators from Build. So all of this new technology, again, converging into constructability, take the process, how they're actually doing it today. And people are starting to question, well, how am I going to build this structure? So starting to look at a housing product or a building product more in the sense of exactly a product and not a one-off project. So reproducible product, but so taking that, expanding upon it just slightly, construction was really contained. A lot of industries were very contained within their space in the past. Now, once you have a clear picture, how are you going to build this structure? How are you going to build this product? The information flow is going to go backwards and forwards. So backwards into pre-planning, design phase. So this is where we're seeing investors like D.R. Horton riding the wave of consumer trends of increased customization, the end user actually having the ability to choose how they want their product to look like. So 3D printing, you choose a product, you get exactly what you chose. The constructability, how it's going to be built, all documented, all digital. It comes out. It's basically pushing print. Then the post-build world is going to start to also influence why and how a building is constructed. So you look at the example like Mexico Beach. The only house left standing was different materials, different build style than the other ones. So actuary tables, insurance companies are going to start to look backwards and say, well, what is in my product? We talk about a healthier building. Again, that post-build world is going to start carrying what was in my building. I want to know when I'm going to rent my apartment, what materials were chosen. If anything comes up in the future that has to be changed out, the post-build world is really going to have easy access when they knew, because it's all documented, all digitized process of how it's built. So we're going to start to see a change of, it's not location, location, location anymore. It's going to start being a building as a product is going to have additional attributes that will be influenced by the consumer and carrying through all the way to rental prices. So how does this all play into 3D printing? Basically, 3D printing is that computer model. So it's early design phase. You're taking it, you're splicing it into layers, and then it's another name for 3D printing is additive manufacturing. So you're adding layer by layer by layer to construct the building. So with that digital model, you take it through a printer. This is a simplified example. This printer here was our early lab version a couple of years ago from we call it our cobot. Our chief scientist on the project is Dr. Varian, so we named it after him. We're using a 1K system. It's a dry mortar mix, adding water. You mix all that together and you extrude out the printed structure with a XYZ plotter. So the big so what of this, again, is that as built is equal to the design. So the product that's on the other side is exactly what the design is, which for people in the manufacturing world sounds like a given. For people in the construction world, sounds crazy. So again, this is the shift of mindset that people from tech community, people from other industries that are not accepting of this 1% low productivity, or, well, just accepting the status quo that, oh no, construction projects always go over budget or always have these change orders. Yeah, that's not the new normal. So why 3D? So productivity, safety, so no form work, less holding time, less people on the job site is all safety, efficiency and speed. So when you're starting to print, once we're at scale, you'll be seeing that there's less waste. The only waste really is the bleed out of the lines. A big one is complexity is free. So this was just this is a desktop modified printer that we took and made just a fun little spiral with, but essentially you don't need to do anything special to do a more complex build. So the luxury market that wants something unique, a one-off product, with 3D printing, it makes it very easy. Logistics, so this could be location. Oftentimes, so you look at the US Army Corps of Engineers, they're looking at using 3D printing for barracks in war zones where you don't want to bring people in. The example I gave earlier with Twente Manufacturing, going to Northern Canada, going to remote locations where you're limited with your workforce. 3D printing offers an easy contained solution to execute a job. And in even Northern Canada there, you also have a small window where you can build. So it brings alternative solutions of a premium product up there rather than oftentimes modular construction that would have been subjugated to the transport and everything of what you could carry up to some of these remote locations. The future value adds, we'll get to in a minute here, but some of them could be like sound attenuation and thermal breaks. So thermal breaks or sound can be controlled just by the print design alone, maybe not even adding secondary insulation or reducing the need for secondary insulation. So the print design is really the basis of what you can be. It's an open platform, reducing material as well. So these are just a couple different printer types. The important thing here is the market is still very much in a prototyping phase. Hasn't really coalesced that one system is going to win out, and it hasn't won out yet if it's going to be offsite or onsite. So both of these are being used, or all of these printers are being used in some capacity, offsite and onsite. The two main ones to note are the gantry systems, which is number 2, and the robotic systems. These are off-the-shelf robotic systems that are modified. So you have ABB, KUKA robots, 6-axis robots, or the Twente with the 9-axis. They mounted it on another crossbeam. But those are the two main systems being used. There are alternatives out there to cementitious mortars, or supplementing them as well. So it is worthy to note. WASP, for example, in Italy, is using a local soil. They scoop it up and grind it and then mix it with a binder system. In Australia, you have Miracle using hempcrete, extruding that out. And then you do have companies using thermoplastic. The picture here is Branch Technology in the US that prints a positive mold and then would fill it in plaster on top of that. Or you have like AI Space Factory. There was a big push by NASA to get a challenge of how do we build on Mars. So using thermoplastics mixed with a Martian-like aggregate. So there are alternatives being developed. And again, a lot is still in the experimental prototype phase. So as Yoni mentioned in the beginning here, we're looking at 3 really key development markets for 3D printing. Dubai being front and center. Edward's going to talk much more about the Dubai market. The big announcement there is a government push with the Sheikh proclaiming that 25% 3D printed components will be on the job sites by 2030. So this is obviously a huge call to action, and has created and fostered an environment to bring that actually to fruition. Another cluster that we're seeing is the Netherlands, and then Singapore is a big developmental hub for 3D printing technology. I superimposed it over the Laticrete network. So This is just where we have plants and facilities globally, and looking to capitalize on those to produce the mortar as local as possible. So what is a 3D printable mortar? There's really three main characteristics behind a 3D printable mortar. First one, thixotropic, or the rheology of the mortar has to be such that you can mix it, pump it. So it has to be fluid under pressure, and then as soon as that pressure is released, it has to hold its shape. So it's extruded out of the nozzle, it comes down, and you want zero slump. You don't want the material to flow out. It has to hold the shape of the nozzle, and then after that, support the weight of subsequent layers. So immediately, well, depending on the print design, so we're talking 20 seconds, we could talk 2 minutes, be buildable to support the weight of the subsequent layers. So this is the term additive manufacturing. Then once all that's done, you want the layers to adhere together to form a monolithic wall segment. So if you look at the picture in the center right, this is a cross section of a pavilion you'll see in a second. When we did the cross section cut, it looks like a single piece of poured-in-place concrete. So you get that monolithic wall segment, all the layers bond together, and it forms one structure. Behind the scenes, again, it's still an emerging market. So a lot of what we're doing is to make sure that this product is available and ready to be or accepted by the market. So the certification, there's a lot. This is a hours topic amongst itself, but we'll talk about it a little bit more in a second. Localization. So again, we're shipping heavy materials here. We're shipping essentially a cementitious mortar mix. So we want to localize as much of the material and produce it as local as possible. And then the calibration factor. So right now, it's not an off-the-shelf product that you can just buy a bag and put it in. To some extent, yes, there are some things starting to coalesce as far as the pumps being used, but there's still a lot of variables out there. So humidity, climate, the different hose lengths, the print speeds, the nozzle itself, the different widths or contours of it. So a lot of variables need to be kind of adjusted and figured out on site. And that's where we're helping behind the scenes to make these, each print look nice. So this is showing a couple examples of projects here. This one is by Chris Battaglia, a project in Ball State in Columbus, Indiana. It was a pavilion for an architectural exhibit, Exhibit Columbus. It's weight optimized, so it's 110 unique customized panels. And the thing that I really love is that it really exemplifies how design can play over into material savings and other value add attributes. So if you look at the size of the holes on the top versus the bottom, that's where you don't need the material. So this structure is completely in compression. And the thicker material at the bottom, you need the material there. On the top, you don't need it. So you left it open and void. So it's a beautiful example of how you can use 3D printing, reduce the material consumption and the overall demand, but still get the full effect of a beautiful building. In Dubai, looking at the United Arab Emirates, again, we localize the material. We produce in Ras Al Khaimah, emirate next door. The product was certified by the Dubai Central Lab and also weather tested. We took a sample, printed in early January, then left it throughout the year out on the grounds of our factory, so subjugated to all the Dubai heat of the summer, and monitor it routinely for cracks, and happy to report that there weren't any cracks left on the printed structure that we left outside. So it definitely performed beautifully, and this is the project you'll hear much more about in detail. And Edouard has some pictures that are going to be released tonight, actually. As we mentioned earlier, the problem in India of lack of public toilets. So this is working with a local Singapore company called Hamilton Labs that has pushed to bring this technology to India. Again, modified, so variable conditions. It's if you look at the printer here on the right side, it's a hand-fed hopper. So we mix the material, feed it into the hopper, and then print prefabricated components that will then be shipped and brought to the job site for constructing these mobile toilets that will be throughout the country. This is a big push by the Indian government to make sure that everybody has access to toilets throughout the country. So we're working closely with the government. There was supposed to be a release earlier with coronavirus and now complete shutdown in India. Hopefully we'll be able to make some more announcements and get this project moving quicker here in the next couple weeks. Singapore, as the host of this, I just wanted to mention again, it is part of this cluster. We're seeing really strong support from university side and from the government side. So NAMIC, the National Additive Innovation Cluster, providing funding, coupling with the strong universities, the National University of Singapore and Nanyang. And so we're starting to see this really strong collaboration hub cluster develop in Singapore. That's just an example we just saw with the India project that was developed in Singapore first and then brought to India. So I definitely foresee much more of this happening. In addition, just a note on the market. So a lot of what we've seen and talked about with 3D printing are standalone one-story or ground plus one structures. A lot of the Asian markets are much denser, so China in particular. So we're probably going to see more in the way of 3D printed facades, components, prefabricated parts that are going to be 3D printed and integrated into structures. So it'd be interesting as the Asian markets really adopt the technology and take off, that we're going to see really different use cases in Asia and Dubai and Europe. Europe is going to be much more productivity, safety on the job site. Dubai pushing the envelope, avant-garde, just adopting the technology really across the board. And then the Asian markets, we're going to see much more of this integration with facade and prefabrication, at least in my opinion. So some of the challenges we are seeing to get a 3D printed project up and going, it's first of all scale. So you take a lab version and a lot of the testing that's been done is at the micro level. It's testing the rheological aspect of one part of the mortar or gel time or something else that's micro, and then you go to take that to the field, and there's definitely a scale-up process that's needed. The second part of scale is we just need to produce more 3D printed houses. And so the villa you saw, I think, was maybe, depending on how you count, around maybe the 20th really complete 3D printed project globally. Probably the first of its kind to be ready to be commercialized. That house will be sold, which is exciting. So that's going to be a big step forward for 3D printing. We'll see what the market taste is for 3D printing, but really we need to get it to where we have a scale where we can get these projects, know exactly kind of that push button model to the use case. Then getting into building code and standards. So right now there are no direct standards. There's a lot of groups that have pushed in this space. The ASTM has a couple subcommittees that were actually supposed to be in Dubai last week. That event and discussions got moved off, or maybe 2 weeks ago. ACI is the American Concrete Institute. They have a 3D printing subcommittee, which is talking about standards for the 3D printing industry. We're sitting on that as a voting member, so we're working with them. Just recently, we see UL also entering trying to play in the standards game for 3D printing of construction. But then still you have to integrate all these standards into building code. And building code is, it's not always as prescriptive. Some countries are more descriptive versus prescriptive. So you're in theory allowed to do some changes to the building code. But this is something where we're still trying to take this product and integrate it in. A lot of what we've seen with the projects globally, if you really look into it, somewhere along the line, something is a concession or an extra or been grandfathered in. One of my favorite examples was Madco 3D's founder, Adam Kuchner, submitted to his local building permit, crossed off all the check boxes for timber frame home, pour in place concrete, CMU block, and wrote in 3D printing. His building, a local building official in upstate New York just said, yeah, we'll accept it. And he got a permit. Other people are outside municipal jurisdictions and under less subjective code. So they're getting in. But expanding on the concessions and the extras needed, this is also what makes it challenging. So while we're in this prototype phase of developing 3D printed buildings, we have to rely on, building, like I said, is 80 trades coming together. So it's also a large product that we're prototyping. So all of these people, architects, engineers, the 3D printing companies, materials suppliers, equipment manufacturers all need to work together. In addition, there's often higher costs being that we're new with the technology. So tenting the job site, providing extra labor, having someone like Dr. Varian on board that's on a job site, PhD scientist to watch cement be placed is not typical on a job site. That's definitely a higher cost. And some of the concessions as far as the building codes to make the structure wider, again, more material than what we envision we'd use in the future. So these are all added costs, which just make a prototype and getting to scale a little bit more challenging. But with that, and trying to leave on the high note here and wrapping back to where I was at the beginning, where I started talking about this 1% increase in productivity. Again, 3D printing is not necessarily going to be the solution for everything, but we're talking about an industry that's 13% of global GDP. It's a massive space for disruption to happen in. And why I call it the Trojan horse, again, it's digitally native technology. You have to understand how you're going to build a structure in the early pre-planning stage. So when you look through this list of where the productivity is going to come from in construction, reshaping regulations, we talked about that, rewiring contracts, people are going to think about these different. Design, complexity is free, consumer demands, again, 3D printing is a solution. Procurement, supply, it's a completely integrated supply chain. And the takeoff is exact one-to-one. On-site execution, again, your robotics, it's a digital twin. The product is what you're putting in the system. So the output is a one-to-one, as built, as matching design. The technology infusing innovation and technology on the job site, that's a given with 3D printing is definitely new to construction. And reskilling workers, training them to be 3D printing operators. So it really hits everything on this list for a future disruption. We just really forcing that people to think differently and ask the questions needed to then make the future more productive in construction industry. So I think Edouard will go much more in depth here about the job sites and a couple examples globally, but open for some questions right now, I think, Yoni?
Yes, thank you, Matt. Very, very detailed and informative. So we have some questions coming in the Q&A tab. Again, just want to remind everyone, do not post your questions on the chat button, do it on the Q&A. We have some questions that are overlapping. We have some questions that already been addressed, but first one is, what is the name of the company for the instant alert badges that you mentioned in the beginning?
So they're an AI company in New York called Quant AI, with a K instead of KWANTI.
Okay. So then we talked about standardization. Regarding compressive strength, are there any compressive strength requirements when we talk about 3D printing?
So requirements, no. Hopefully, maybe that was a Laticrete question. I planted, I don't know. But so interesting, just a note on compressive strength. What we've produced as far as our material, it's a very highly engineered, you might even argue over-engineered material. So in PSI, we're talking over 5,000 PSI. And oftentimes on job sites, you're looking more at the 3,000 level for the areas that we're placing this material. So there's no requirements as of yet. each project is ad hoc, working with structural engineers. So it's not just the compressive strength, but it's also the flexural and the whole assembly. So we're doing it ad hoc with structural engineers to get the sign off right now.
Okay, so I guess building on the strength component of 3D printing, some of the questions we're talking about the use of rebar. Is it being used at all? If so, how? If you can talk about that, please.
So there is a company, Rebar Tech, I believe they're called, that is starting to automate the placement of rebar cages. There's another solution that is being used in the Netherlands by Baakilini. They're integrating a spool of metal into the 3D print. As far as completely replacing structural rebar for flexural reinforcement, there hasn't been, as far as I've seen yet, a completely automated solution that's going into a 3D print. Oftentimes it's being done manually after or in sequence added manually. There's also structural reinforcement columns that can be incorporated into the print. So you have the structural slab, you can have the rebar tie in, and then have a structural column that would be filled in after.
Okay.
So several solutions, but it hasn't been completely automated yet.
Okay. So just because of the timing, I would like to end it to Edouard at this point. Please note, some of the questions that have been posted will be answered and addressed by Edouard's presentation. And if we don't get to your question, we will answer it after the webinar. We'll make sure. Okay, Edouard, please.
Good morning, good afternoon, good whatever you are in the world. I'm happy that you're with us, and I'm hoping that everybody is keeping safe with the current pandemic. Thanks, Tony. Thanks, Matt. Again, my name is Edouard Baakilini, and I'm the CEO of 3D Vinci. We are a company that is based in Dubai. I will talk about the company in a minute. The title of my presentation today is Concrete 3D Printing, a welcome disruption in construction. And I'll talk about why it is welcomed right now, especially under these circumstances. So briefly, I will go over the current technologies, some sample projects that have happened in the world. Why is 3D printing needed? Why do we have to have 3D printing? What are the challenges with 3D printing and the opportunities as well? And then I will also present as much as I can about the 3D printed villa that we did in Dubai here recently. So our company was established in 2014 in Dubai, primarily to provide 3D printing services to the local area, to the GCC countries. We started primarily with printing in plastics and some metals to architects and prototypes, consumers, figurines, toys, this kind of stuff. Now remember, in 2014, concrete printing was not a primary business. And then 2016, we shifted into concrete printing, and we got the first project here in Dubai to do concrete printing in situ. I'll talk about this in a minute. And actually, since then, we've been primarily focusing on concrete printing. That's what we do in Dubai and the GCC. And the purpose is to be able to provide concrete printing solutions for the construction industry. We're talking about houses or structures, outside furniture, facades, any of the stuff that involve concrete printing. We are working with the local developers, architects, government entities to be able to provide processes and materials and consumables and the know-how and training to be able to make this a viable and sustainable business in the region and hopefully globally. So what is concrete printing? Just 3D printing in general, what is it? 3D printing is additive manufacturing. What it is you basically just add layers on top of each other as you're building a product. And in this case, we're talking about concrete. It's the same concept in plastic or metal, just with, instead of subtractive manufacturing like you do with the CNC milling, here we're just adding a layer by layer on top of each other until the structure is formed. The only thing that you need in 3D printing is basically the printer, and then the raw material that you're using to produce your product, and then the software to tell the printer how to do the product, to build it up from zero. Now here's an example of concrete 3D printing that we're doing here in Dubai. This is for the villa, so this is an actual video, and in the video that you see some of the rebars, and I will get to that later, that we're printing around. So you can see that we are forming layer upon layer, and in this case we're using the Laticrete material. And you can see that the printer is basically executing without any intervention from any worker the design that we did. Now, what are some of the current printing technologies that are available globally? There's a whole bunch, but these are the main four technologies. There's the gantry system that you can see on the top left. There's the robotic system, which is basically just a robot that you can print. And then you have the telescopic arm. And then you have a hybrid. You can have a robotic arm that is on a gantry system that moves in different directions. So you get multiple freedom of access, multiple freedom of the movement. And you can, in that case, do very, very complicated design. For the project that we have done in Dubai, we've used the robotic system, and we've also used the gantry system. So these are some of the sample projects that have been done globally. Now, most of these projects have been done in a controlled environment, a proof of concept, if you wish. These were not occupied by people in general. Nobody lives in them. These are like show and tell type of projects. So there's first the Bulb, the building on demand project that was done in Denmark by Copod using a gantry system. And then we have the project that was done in France, also at the university site at Nantes. There's also the 3D printed house that was done using the wasp soil that Matt previously mentioned. Some other projects also by Winson. Winson have done a lot of prototypes and projects that are you can, if you go to China, you see them, they will show you these projects. Some are pavilions. They've done a 5-story building also. There's also this nice project in Netherlands that is being done as we speak. In Dubai, there was the House of the Future that was also executed by Winson. It was prefabricated in China and shipped to Dubai and assembled in Dubai as well. There are a few projects also in Manila and in Russia. In Dubai, 3D Vinci was involved in the two main in situ projects that were done here in Dubai. The first was with the DWAD, the R&D lab drone, which was an office, 140 square meter office that we did with Saibia, and it was using a robot. So basically what we're doing is we're printing panels and moving the robot. And then recently, as of few months ago, we did the first 3D printed villa. It's actually the first commercial villa that I know of in the world. So it's a villa that was built to be sold in the market, just like any other villa. But instead, in this case, it was 3D printed in full. I'll talk about it in my next presentations. For this particular technology, for this particular project, we used the Copod printer and we used Laticrete material. And we went through the entire process of getting the approvals, the designs, all of the stuff, as if you do it with a regular villa. And I'll get to that in a minute. So why do we need 3D concrete printing? Why even bother with that? Well, 3D printing actually answers several shortages and forthcomings when it comes to the construction industry. There's a global labor shortage. There's a affordable housing shortage, rising construction costs, as we all know. as well as having an eco-friendly, sustainable, and viable construction technology. And we believe that concrete printing can actually answer many of these concerns. From a labor shortage perspective, we can see that by year 2030, most of the country will actually be facing big labor shortage. You're already seeing it right now. And I think with the COVID-19 and the pandemics and the diseases, everybody is trying to move into a smaller labor force to be able to minimize spreading of viruses. But even if we put that aside, there's already a big shortage that is being that is actually coming in the next by year 2030. From an affordable housing shortage, I think everybody knows that there's a big globally, every country, take any country in the world and you will see that there's a shortage of affordable housing. Estimates by McKinsey Global Institute find that there's 330 million urban households that are living in substandard housing. And there is no solution for that right now because of the construction costs, because of the speed of construction, because of availability of labor, because of all of these elements. We are not able to answer this kind of shortage. And printing can actually be can you hear me? I got a message here. Okay.
Yes.
All right. So, the global shortage of affordable housing is a real thing, and 3D printing can actually be a serious and reliable solution to answer this shortage. So, how does 3D printing help with these kind of issues? First, reduce labor costs. In 3D printing, the labor cost to build a house, when talking about the walls, the columns, all of this can be done using 2 or 3 employees, 2 or 3 laborers. You don't need the whole army of laborers, and I'll talk that in a minute later. Reduce materials. There's practically no material wasted in concrete printing. What you need is what you use is what you need. There's no formwork, there's no tools, it's just a computer and material and a couple of laborers. You can actually also improve the design for free. Matt mentioned complexity is free in 3D printing. Same thing. You can do really improved design without having to add any cost to your building. One of the important aspects here is when you look at some of the houses that you go around, is they are blocks. I mean, many of the buildings. It's like, you know, all the houses are the same. With 3D printing, each client can have their own house customized to their needs without having to pay any additional cost. And the reduced duration of construction. You know, usually villas, houses, buildings take months, years. With 3D printing, now we're talking about days and weeks rather than months and years. So again, anytime you introduce a new technology, you want to see that it is faster, cheaper, and better. And we claim that 3D printing can actually do that. From a customization perspective, you can do more intricate designs as an architect. You can mass customize it to the different clients. From a cheaper, the initial calculation has shown that it can be 50 to 80% lower from a labor cost. As well as I will discuss some of these in details later on in the presentation, waste in terms of formwork and others, as well as if you look at the total cost associated with construction, because you have a shorter duration, then any financing will also be much less with 3D concrete printing. And it's faster, definitely it's faster. I mean, we finished the villa in 4 or 5 days of printing. That's how fast you can actually do your projects. So when we come to 3D concrete printing, we are basically digitizing construction. And what we say is 3D printing actually holds the premise of turning the construction industry, of transforming it into the digital era. I know it's construction industry is a very traditional, very old industry, but now we have technology that can actually move it into the digital era, just like many of the other industries in the world. It is disruptive in nature, definitely, and that's the challenge. What you're gonna do is you're gonna have to basically change the entire scope of how construction is approached. 3D printing service, I'll show you a slide in a minute where the new model is completely different than the old model of construction. Usually the construction industry is linear, vertically and horizontally. With 3D printing, it's more circular. The designer, the architect, the client, the 3D printing provider, the material scientist, all have to be involved at the onset of the project so that it gets done properly and it gets done fast. Many of the organizational roles, many of the responsibilities, many of the activities, many of the skills, the supply chain will be completely disrupted with 3D concrete printing, to the better, of course. So the new model of 3D printing is a collaborative model. And we've seen it in the projects that we've done, where basically we applied, and you know, obviously because, you know, no one is, it's new to everybody. So in the projects that we've done here in Dubai, we were following the traditional way clearly, and obviously it was clear that that didn't work. Whenever you start with the client, you know, you have to set their expectation in terms of what the concrete printing can and can't do. The architect needs to be what can and cannot be done, as well as a contractor, setting up the supply chain, setting up the roles. You know, all of these are completely different with the concrete printing than with the traditional construction. And at the heart of this is definitely the consulting group, which has to put the entire team together, the service provider, the design team, as well as the contractor. So if we want to, again, compare concrete printing to traditional construction, you know, with traditional construction, you'd have the concrete blocks manufactured somewhere, then you have to transport the blocks to the site, and then you have to have some skilled labor being able to work with the blocks, and you get a whole bunch of waste and garbage that you have to manage as well. It takes a long time to do these houses, big labor force, and basically it's difficult to scale. I mean, you have a whole army of laborers if you have a big project. All of these can be answered by 3D concrete printing, meaning that you can only have the material on site. You don't have to have it produced in a factory and then shipped. The printer usually is on site, so the printer is in situ printing. You don't need to do all of these transportation, so you cut on transportation costs. Skilled labor, you only need 2 or 3 laborers to operate the printer. Material, there's no material waste. That's all you need. We'll talk about that in a minute more. And then it's in a few days you're done with the building. So this is an illustration of what I was talking about. In the top, you see the traditional way of doing the construction, where, and you can see the scale. I mean, just by looking at this particular graph, you can tell that the concrete printing in its disruptive nature will make the construction seamless, viable, sustainable, cheaper, easier. But the key to all of this is the mortar, the concrete mix. And I think Matt talked a little bit about that, and I'll also mention it briefly. So someone was asking about the compressive strength, and yes, most of the material can be customized to have a certain compressive strength. You can add plasticizers, retarders to it. You can change the mix. And again, I go back to the collaborative model where when the design is being made, when the project is being launched, all of these has to be taken into consideration. So right now with the Laticrete material we're using, it's achieving a compressive strength of 35 plus megapascal. And I think that you can actually custom make that to reach a certain compressive strength as well as flexural and tensile. Again, the material has to have optimized layer bonding and adhesive, because you know as you're depositing the layers on top of each other, they have to really bond, they have to adhere together, And it's not only in this case just the parameter or the material itself. Actually, there are other materials. I will not get into the details here, but there's the speed of the printer, there's the humidity and temperature, ambient humidity and temperature that also affect these kind of things. You want also the material to be homogeneous. So when you take a cross section of that wall, you don't want to have areas where there are bubbles or there are voids, so you want it to be homogeneous. Again, flowability and rheology, Matt talked about that. Workability and buildability. Also, all of these are details that I will not get into here, but these will go all into the concrete mix itself. And right now, we have a good material that we're working with. We're achieving these kind of numbers and these kind of results, and we're able to be able to do our projects. And most importantly, of course, again, is that it has to be locally sourced. Many of the materials are either produced elsewhere, and then you're back to the same point where you have to ship that material, you have to incur high cost of transportation and high cost of storage. So all of this is also important as part of having a viable technology. Here I want to give you an illustration of what we're talking about in terms of, you know, doing a small house, let's say, using a gantry system, which is, in my opinion, is the way to go right now with the gantry system or a variation of a gantry system. This is just an idea. You can have different gantry systems that doesn't have to be like this, but in principle, it's the same thing. So the process here is an illustration, and we followed this in our project that we did here in Dubai. Sorry. All right. So basically, what we do here is we start with a slab, a floor slab, just with any regular building, any other house, and you can see the rebars in the slab itself. And what we do is we start printing a double wall. Again, this is just an illustration. The way you approach a project is different from one project to the other. In this case, the walls are about 5 centimeters with a void of about 10 centimeters. Again, this is just an illustration. The real dimensions, the specifics, all depend on the design itself and on the structural analysis that needs to be done. Sorry, guys. So right now what we're doing, the printer is printing, and like you see, it's printing around the columns, and everywhere that you see a void, that's where you'll have the windows and the doors. We are also printing the internal divisions inside the house, so the internal walls are also being printed at the same time. And you can see that there's absolutely, from a labor perspective, you know, there are only 3 people there. So, and you'll see it in a minute in a live video how it actually works. And then what we do is we put the reinforced concrete and we pour the concrete in. Then we put the cement boards. We continue the 3D printing. Basically, right now we're preparing it for the roof. In this case, we're doing, the roof can be anything. It can be in situ pouring of the roof, or it can be hollow cores. And once we're there, we also come and finish it with basically with the parapets. This is a typical, I think you've seen this before, so I'll just move on. So what are the opportunities that we get from 3D printing? First, you get the construction of complex shapes at absolutely no cost. You have product integration in the construction itself, mass customization. construction automation, and faster construction time, and I'll discuss each by itself. When we talk about the freedom of design, this is some of the stuff that you can do with concrete printing, and this is something that we did here in Dubai. You can see that it's double curved with about a 20% overhang. Some of the stuff that you can also do, these can be columns, for example. So these can be the column inside your house that you can pour concrete in. And all of this, again, at no additional cost. You can do wall designs as well. So you can program your printer to be able to do these kind of intricate. Some of the projects that we're involved in right now is where you have different walls of the same villa, some of it with this kind of design, others with maybe more straight lines. So it's open. For an architect, it's really a nice tool to have. You can change the walls without really adding to the finish later on in your project. Reduce material waste. The biggest material waste, the biggest reduction in material waste in 3D printing comes from formwork and water, but primarily from formwork, because mostly formwork represents between 30 and 60% of the total cost of concrete structures. So by eliminating that, by basically having your formwork 3D printed, you eliminate, first of all, the waste, and you eliminate the time that you have to take in order to build these formwork. So here in this case, on the left corner, you can see that the concrete, the 3D printed concrete is the formwork for that particular reinforced column. Same thing in the middle. And on the right-hand side, you can see that the right, I don't know if you can see it, but in the middle, you introduce the column that is as part of the design itself. It's not something that sticks out. So it's integrated within the design itself. Less labor again. With 3D concrete printing, because you don't need formwork, because you don't need block works, and potentially we don't need any plastering and painting afterward. Many of the materials can come in a different color with different dyes, so all of this can be inputted, can be part of the initial design, as I said, when the project is being launched. We only need 3 workers to run the printer, and it's all accessories, being the pump and all of this stuff. Of course, less laborers mean less transportation, less accommodation, less social distancing. So all of this will actually lead to more sustainable, viable, cheaper construction, as well as accidents. So what we want to do is we want to go from, I don't know if you've been to some of the construction sites here in Dubai and the GCC. Basically, you have armies of laborers. Buses come, they pick them up, they take them to where they live. What we want to do is we want to be able to go from a traditional construction of armies to basically 3 people who are operating a printer. And again, you want to go from all of these tools that we're used and waste in traditional construction to basically having a laptop or a mobile phone or computer. Product integration. Again, with 3D printing, you can integrate MEP elements within the design itself, in terms of the piping, in terms of the outlets of your electrical and sanitation. So all of these can be accommodated within the design itself at the onset, and that's why it's very important to have all of these set up at the beginning. When I talked about the collaborative model, where you have all of these clear from the beginning, and then you can start printing and going with it. You can also include, because you have this void between the 2 walls, you can introduce foam insulation or different kind of insulation. Some insulation right now, the printer can actually pour that insulation inside, so you don't have additional equipment that needs to come to do the insulation itself. Also, we're working on 3D printed slabs, roof slabs, again, but this is still in development, but it's coming. Now, from process automation, because we're digitizing, because we're moving into the digital area, we feel that concrete printing, 3D concrete printing, can actually escalate the speed at which we can digitize construction. I will not spend a lot of time on this block and on this flow work, but the central part of construction will become the BIM model. So from starting from the conceptual design and then into architecture, and we feed it into a BIM model, then what will happen is that the CAD file will be checked from printability. You do structural analysis of the design itself. All of this can be done with software tools, and we're already discussing that. So you can use finite element analysis. You can do topology optimization to be able to have the best design given the parameters of the concrete and given the parameters of the design itself. And you can basically iterate in this area where you have the BIM design being reanalyzed, compatibility. You do the topology optimization until you get to the point where the client is happy with the design itself, and then you are ready to send it for approval. Now this can be sent to the approval online as well. So there's no need to go to the municipality or to the authorities. And then again, you go through the same iteration where if there's any online calculations or corrections that needs to be done, you can go back to the BIM model and go through it until you get to the point where you have the approval online. Once you have the approval online, you can mobilize the contractor can mobilize, and you can also move the 3D printer to the job site. You set up the foundation slab, you set up the printer, you do the calibration, you have your material, the supply chain already set up, and you start printing, and that's it, and you're done. This is how simple we believe this can be. And if we throw AI into the mix, this can also be even further reduced and further automated. Oh, this is the nirvana of where we want to go, but I think it's doable and it's not too far into the future. So again, from a process automation, what we're doing is we're trying to cut many of the time-consuming steps, especially when it comes to approval and bureaucracy and all of this stuff. Structural analysis can be done using finite element analysis, using new tools that has to be developed. We can do topology optimization as well. When we're doing the project here in Dubai, our team, the 3D printing team, we had the computer with a 3D model, and that's all we needed. Whereas the other team, the contractor, they were bringing stacks of 2D shop drawings, and you can see the contrast. And I think that eventually we don't need any more 2D shop drawings. This will be obsolete. Again, also from a process automation and in the world of data, big data, the printer itself can keep many of the parameters in terms of speed, humidity, all of the metrics, and it can be basically saved and for later analysis, for later somebody wants to go back and see what's happening. So all of this is digitized. There's no need to take any manual entry for that. Again, everything is in real time when you automate and you digitize the process. So again, from a sustainability perspective, less trips to the municipality, less trips to the authorities, no paperwork. All of this become automated. So the project that we just finished here in Dubai is a 3D printed villa. Again, this is probably the first commercial villa ever. I know in Dubai, but in the GCC at least. But I think globally, where this villa is actually on the market and being sold to customers who are going to actually go live there. So this is how the villa looked like after it was done. So this is in its, let's say, before we did any work on it, this is how it comes out. And now this is how it is. Really nice work. We believe that the architecture can be a bit more challenging, can be a bit more taken to advantage the power of the concrete printer. So these are additional side views. And you can see the curves and the curvature. There's no additional cost to that. done, you know, there's no need for skilled labor to do these kind of curves. Again, different views of the villa. And you can see here the edges where they come. I mean, again, I get free. There was no additional cost to that. And all of this was done in 5 days. The villa was printed, was painted. There was, we didn't do any plastering or any, just basically painted it in with this color. These are the internals. So, so some of it we did do some plastering. We did, but the client wanted to show some of the walls still as in their native 3D printed look and feel. So, in the age of coronavirus and pandemics and social distancing, I think we can say that 3D printing is probably a really much needed welcome disruption. Why? Because in 3D printing, all you need is this. This is actually a video from when we were doing the villa in Dubai. There were only 2 laborers, and this probably was like after midnight. And the printer was printing. We had a computer and the guy behind the camera filming the printing as it's happened. I think that the video speaks for itself. That's it. So the future is here. Right now, after the success of this particular project with Laticrete, the client is interested in scaling this, and this brings, like Ahmed was saying, brings its own new challenges, going from one villa to multiple. We have to define many of the issues of supply chain, with organizational roles. We have to do a lot of training for the contractor in this case. So you know, I think that the future is here. Dubai is definitely on the leading edge of this. They are really pushing this technology, and hopefully that we'll have many lessons learned to be shared with everybody in the world on how to take this technology and make it scalable, cheaper, and better. Thank you. Any questions?
Thank you, Edouard. Beautiful villa. Can I get one of these days from you? So some questions that came through. Once again, we might not be able to get to all of them because we're a little bit over time, but we will directly via email. We respond to each question. Regarding height, Edouard, is there any height limitation when we're talking about 3D printing?
Yeah, right now the height is limited by the printer itself and the feeding system. The state of the art of height right now, the best that you can do with the available technologies in the world is about 11 meters. So you're talking about G+1, maybe G+2. And I know for a fact that G+1 can be done. We're working on that. This is part of the work that we're doing right now. Hopefully we'll want to be able to do G+1 without much difficulties from the municipality.
Okay, and regarding height or the external
height,
panels?
yeah, the height is 10 meters. So so if you have each floor about 3 meters and 3 plus something, 3.2, then you can do 3 floors, 3 stories, G+2. But we can, you know, right now we know we can get G+1 easily.
Okay, and there was some question regarding installation. How do you address installation?
I showed in the presentation, installation can be done in different ways, again, depending on the design that you do. What we have is you can have a double wall where you have a 3D printed wall void, another 3D printed wall, and you can put your installation between the void, in the void between the 2 walls. That's one way. The other way is to have just a 3D printed wall and then apply a drywall and put the insulation in between.
Okay. Regarding fire resistance rating, is there any fire resistant rating on 3D printed walls?
It's, you know, it's concrete, so it's very, we do, but you know, it's just it's very hard, strong, durable concrete. So the fire rating is fire rating of any concrete.
Okay, and you mentioned durability, and we all understand that this is a new technology, but is there any estimation of what will be a lifespan, the durability or lifespan of a 3D printed, call it home, compared to a traditional constructed home?
When you say traditional, you mean blocks, concrete blocks?
Yeah.
You know, like you said, we don't have real data. I mean, this is new technology, but I think that we've done some work where we tried to do in the lab, where we tried to see what kind of durability we get. We can, you know, safely, honestly, safely, we can say that 3D printed houses and villas, you're looking at tens of years of durability. Do I have the proof? No, because no structure exists right now. But just knowing from that it is pure mortar, pure concrete, with not much aggregates or additives, you can, you know, from a logical perspective, you'd imagine that it's going to be long living structure.
Okay. You talked briefly about the software that is being used. Can you talk a little bit more the name of the software or type of softwares that are being used currently?
The software that we're using, there are different software, right? So there's the software that is used for the printer, and it's just a regular software that's freeware that is available that does G-code generation for the printer. Now, in terms of the software that will do the finite analysis and the topology optimization, this is still in development. It's not there yet. So this is something that is being developed as we speak. And you know, many big companies are interested in this. We're talking about companies like Autodesk and others that are happy to develop these kind of software where it will help with the analysis and the optimization, but it's not there yet, honestly. Right now, what we do is we take existing software for design that is there, whether it's 3D Max or SolidWorks, any of these products that we can do a 3D design, and then we turn it into a G-code, and we do the structural analysis using traditional structural tools.
Okay, thank you. Regarding, so as we saw in the videos and some of the photos, the finished layer is a rough surface. How do you address if you want to get a smooth looking surface?
Yeah, you can plaster it, you can cover it, you can put stuff on it as well. You know, you can put small blocks if you want to do that. It can be plastered. We've done areas where we smoothen it with plastering. I know Laticrete is working on the material that has, let's say, I mean, there's no running away right now from having these lines in 3D printing, but you can have them where they are smoother. And some of the things that you can work with are, for example, not just the material itself, but you can also work with the nozzle, the print head. You can develop nozzle where you can smoothen the surface as you go. So this is work in development that we can able to do that. Or you can actually, some other stuff that can be done is the printer itself can have additional utilities on it where it smooths the surface after you print. You basically have a window of up to 1 hour, maybe an hour and a half, where the concrete is still, it's possible to smoothen it without damaging it before it cures fast. So this is some of the stuff that we're working on.
Hey, Yoni, if I can just add to that, so this is a prime example of where collaboration is really needed in this space, with this idea of feedback loop, that what's being extruded and what's the finished product is communicating with the equipment, and that all the partners are aligned in what their vision of what it should look like aesthetically. So once we really optimize the flow control, so you have the mortar extruded and then being contoured at the same time, but really controlling exactly how much material is extruded in collaboration, so that that window of flexibility of how you can work with the material. So this is where other robotic solutions are going to be incorporated into the print head or brought onto the job site. So this is a prime example of just the collaboration that's still in development.
Perfect. So there's some questions about cost, but I believe we cannot give exact figures. We're talking about the reduction, the massive reduction in labor. Of course, no wastage on the job site, safety, etc. So we don't have exact figures, but we're over time. So just before we end, I want to thank our presenters again, Matthew and Edouard. Fantastic job, a lot of information. As I mentioned, please, you can contact us directly. Our emails are below. If we didn't address any of your questions, we apologize. We don't want to run for 2-3 hours of a meeting right now, so we will address them via emails. But please feel free to contact us if you have any questions, inquiries, if you want to learn more, do more, let us know. We're here. And thank you all for your time. Thank you for joining.
Yeah, thank you, Yoni. Thank you, Matt. Thanks for everybody who joined.
All right. Good night. Good morning. Thank you, Edouard. Thank you, Yoni.
Thank you all, and be safe. Be well and be safe, everyone. Take care.
Yes, exactly. Take care.